of the trailer park.
Did your concert already go by?
No, it's coming out. But there's difference. I saw real country music and
Did you
pandering.
get that? Didn't wreck my truck? You know, like, no, it's supposed to be coming up here too.
Oh, great.
All right, y'all. So, we are on to a new chapter.
Your lexicon's too big for the level that you're going for.
I
Trust me.
like y'all because we don't have a collective you.
Ewan's.
Ewans?
No, it's a real
Ewan's
thing.
is worse.
Yee. Ewan's is a real thing.
There's so much, yeah.
I think y'all is better.
Thank you for.
I also feel like y'all is something that like it makes you just seem more relatable. And as someone who needs that sort of relatability aspect sometimes, that's good.
Yeah, because y'all is,
Yeah.
all y'all is everyone plus everyone else. So,
As someone from this portion of the world, I refrain from saying those words.
So, we are moving on to chapter 4. So, chapter 1, we did some stuff that was about, like, what is measurement? What are we doing when we're measuring? That type of stuff, right? And that was really cool. And then we moved on to signals, and we did a lot of different analysis of signals, like Fourier analysis, line spectra, Fourier transforms, all that. And then we learned about how to interpret a measurement system as a dynamic system. Okay, and then we learned how to analyze, especially we spent some time on first and second order dynamic systems. So we have one last theoretical adventure to take, and that is probability, statistics, and estimation. I mean, it's like a like a conglomeration of some. It's one broad topic. So chapter 4 is on probability, statistics, and estimation, and this is the sort of the last highly theoretical part. And it's not even that theoretical, it's very much practical, and I think that you guys can understand how it's practical. But it does involve maths, so there's that. More maths. I would say the maths are easier this time. Not as many integrals and stuff. Integrals, yes, but not as many. And I find this stuff really, I think, kind of fun. And I actually, I think that machine learning and artificial intelligence-based technologies are going to increase in frequency and application. And a lot of that is based on probability and statistics. So I would mention that too. So like, it's not just like, I think prob and stats kind of has this like, ooh, it's really boring kind of a connotation to it, because like statistician, like I couldn't think of a job. Okay, accountant. That sounds more boring. As like, I mean, like a desk job that sounds more boring. Okay, I can't make this better. It's just bad. But probability and measurement theory actually, and statistics and estimation have a lot of really cool like machine learning applications and stuff. So intelligent systems use a lot of this. So it's important. But it's also important just to be like an intelligent person in the world. And as an engineer, like you also have to take a class that involves some engineering economics.
remember that class?
So you took it already, yeah. So GE 359, and it's considered to be an aspect of being an engineer is being able to do some engineering economics sort of calculations. And this is part of that.
I found that in terms of doing the actual computation in using pay, but in terms of actually understanding how economics works, manufacturing is much more effective class. Because the manufacturing, you don't have to do the math behind the economic decisions, but you have to know the concepts of choosing the best economical processes or ideas of how to get something done. Whereas the economics course was just like, here's some math formulas that are longer than my calculus problems. And here's the calculates percentages of ratios of things. I'm like,
Yeah.
It was too in depth. I'm like, if I saw this, if my boss sent this to me, I'd send it to accounting. So
Yeah. Yeah, it's
it was.
I don't know. There are some aspects about it, but I think that this is generally, it falls into the like probability and statistics. Being able to do some basic stuff in it falls into the like general skills of an engineer. Like you should be able to do a little bit of economics, a little bit of statistics, and I think that anytime you are working in a technical field, you have to be able to understand and interpret experiments, right? And this is the way that we do that. Like we understand and interpret experiments through probability and statistics. So knowing, for instance, how well you know something, remember that we talked about that in the first chapter. A lot of that, one of the ways that we come up with confidence intervals and whatnot is through statistics. So it's useful. Yeah. We'll talk more about it. And actually this is I've many of us on the faculty believe that probability and statistics is a really important topic for you guys to know. And unfortunately, they won't just let us add that on top of your curriculum for some reason. Something about like too many extra credits that you have to take.
136 is too many, but 133 is just right.
So, but the idea is that this course is supposed to introduce you to at least some of the prob and stats that you should have. So that's why we're going to take a few weeks on it to really like make sure we have a good grasp of it.
That's good because I need to review it. I took it last semester. I didn't do well on it.
Well, good. There you go. Yeah, and I actually, if you've taken it before, then that will help you immensely. Might be a little bit different the way it's presented here, but same stuff. So, are you ready for the first lecture? So, probability and measurement. Oh, by the way, Friday, I'm going to give you guys your exam, and you're going to have it for...
The weekend?
I think it's at least going to be the weekend. I'm thinking probably a week.
Oh, wow.
Yeah. Yeah.
Because we have a heat transfer final midterm.
Yeah. I heard some stuff in the back, but I couldn't tell what they were saying.
We sit in the back, so we don't count. Give it to us Monday.
Okay. Yeah, but I'm probably going to give you longer, though, because it's probably going to require more work, so I'll probably give you more time. Okay, probability theory. First lecture on probability and measurement. So probability theory is a well-defined branch of mathematics. Andrei Kolmogorov described a set of axioms in 1933 that are still in use today as the foundation of probability theory. We will implicitly use these axioms in our analysis, but we're not really going to go back to the axioms because it's easier not to. The interpretation of probability is a contentious matter. So probability theory as a branch of mathematics is like not super contentious. It's the interpretation that is pretty contentious even still. Some believe probability quantifies the frequency of the occurrence of some event that is repeated in a large number of trials. So this is the so-called frequentist interpretation. Okay. Others believe it quantifies the state of our knowledge or belief that some event will occur. All right. This latter one falls under the heading of Bayesian probability. So we will be using a little bit of both. Interpretation, though, overall is not explored in detail in this course, but it is relevant. We will use a Bayesian probability method later in this chapter that requires a certain perspective. That probability is a quantification of belief or knowledge such that one can have a certain occurrence. I think I need some work on this sentence, but essentially, the probability is a quantification of belief or knowledge, and not just how frequently it occurs when you do large numbers of tests. So there's something that I'll point out when we get there, but if you want to read ahead, you can look up Bayesian. Well, that might lead you down a long rabbit hole. But if you Google at least the Monty Hall problem, has anybody ever heard of it? It's a very famous problem.
Monty Hall.
Okay. I'm going to prove to you guys that this stuff's actually kind of interesting by telling you about the Monty Hall problem. Okay, so there was a game show, and I guess the game show host was Monty Hall.
Yeah.
I don't know, but they had in this game.
Oh yeah.
What was it?
Door 1, door 2, door 3.
Okay, yeah. So there's 3 doors, and behind 2 of the doors are goats. And behind one of the doors is like a car or something. I don't know, the prize. And
They made a movie off of this theory.
yeah,
Or at least this concept was explained in a movie with
Really?
Kevin Spacey was the teacher.
that's cool.
You're talking about 21?
Yeah.
Yeah. The Monty Hall problem, it pops up in a gambling movie where you count cards 21.
Huh. Who
Yeah,
knows?
watch the movie 21.
Oh.
Movie day.
It's on Netflix now.
All right, I will.
Not a bad
It's not that great.
No, it's not the great movie, but you know,
Monty Hall problem.
the scene was good. you know,
It's early in the movie, so you don't have to go too far.
So the idea is for those of you who haven't seen 21, the gambling movie with Kevin Spacey, the idea is that the contestant is told that there are 2 goats, 1 prize behind the doors, and then Monty Hall opens one of the doors, and he always shows a goat, right? So oh no, wait, no, I skipped a step. This person had to choose a door, okay, first. Choose a door, 1 out of 3, choose a door, and then Monty Hall says, okay, I'm going to open this other door, and there's a goat behind it, okay? And then he says, would you like to keep your choice, or would you like to change? And you think, okay, they had a 1 in 3 chance, now they have a 1 in 2 chance, but like it doesn't matter which door they picked. It matters. They should change their choice to the other one. Which
What, 90% of the time, it's always the other one.
I don't remember the percentage, but it's I know. It's like
it boosts if you were to pick the other one, you get, instead of like a 33% chance of selecting, you get like a 66% chance because of you took out a variable, so the variable is now going to.
yeah. So when you chose the first time, you had a 1 in 3 chance. When you chose the second time, you had a 1 in 2 chance. So your probability increases. So
Honestly, I'd rather have people really bad than 100 trains.
so
You can be friends with Jung.
I want to. So this problem was actually, I believe it was published somewhere. I don't know. It was like New York Times or something. and like everybody freaked out. It was like the blue dress,
No, God.
yellow
Sorry,
dress
you're
thing.
starting to do that with a shoe now?
No, oh
It's not gonna
god,
take off this time.
yeah. So like, you know how like the internet lost its mind over that?
The newspaper lost its mind over this.
Yeah, like so like everybody back in the day, it was like everybody lost their mind over this problem, and like there were mathematicians and statisticians like we're on both sides of this, just like no way, you're so wrong. And then I think that I don't know how it was resolved exactly, but you can do this, and I actually want us to do this in the class, but you can simulate this. So we could simulate this, and it turns out if you simulate it,
Be a good project.
incredibly, you don't. It is actually better to change your choice. So, fun stuff. So, probability is not like always dull and boring. It's kind of interesting. It's kind of cool. In experiments, our measurements are tightly coupled to probability. This is apparent in the questions we ask. Here are some examples. How common is a given event? Something you might want to know. What is the probability we will reject a good theory based on experimental results? How repeatable are the results? How confident are we in the results? What is the character of the fluctuations and drift in the data? How much data do we need? Those are the types of things that we are often interested to know when we're, say, designing something and we have a prototype of it, let's say, and we're like, okay, let's test it under certain conditions. And then you immediately want to know, like, all of these things, right? And so statistics, probability and statistics help you to answer some of these questions. Or at least they give you a framework in which you can start to answer them, or at least come up with reasonable answers for them. So that's the motivation.